got a problem that is looking at, at pyridine, which is C5H5N, and it's wanting us to find the H plus concentration and the pH off of a given molarity and Ka. So I can tell right away that this is a weak sample because it's, well, it's not acidic, but it's a nitrogenous base. So I know that I need to take my C5H5N and we'll add it to water, of course, because that's how we analyze pH calculations of weak samples. So we're going to have a Bronsted-Lowry interaction here. Again, I've decided that this guy is basic because of that nitrogen included in him. So he's a weak base. Now, I know that Bronsted-Lowry states that bases want to gain a proton. So an H plus is going to travel from the water to the base here. So it's going to look like this after that happens. Just add it on to the end. So there's the extra proton. Now this guy is missing a proton. So he turns into hydroxide. So, of course, we're going to do this in a rice table. I know that in my rice table, we can ignore water because it's liquid. All right, and then going back to the problem, one of the given values is 0.44 molar. So I've got an initial concentration given to me of 0.44. And then these guys are going to start zeroed out because there's nothing there. My shift then is going to be to the right, always towards the zeros. I plus C equals E. All right, so let's join these together. All right, and now here's where we look for another given in the problem, and if I go to it, I have a KB. All right, it lets me know that the KB of the reaction is 1.7 E negative 9. All right, so this is a given value that we can now use to continue my analysis here. So if I want to plug this into an expression, I know that my unsubstituted would be the KB with the products over the reactants. All right, so there's my unsubstituted, and now we can put in everything that we know. So I have a KB value of 1.7 E negative 9, all right? And I can set that equal to both of these, which look, they're both x's, so x times x is x squared, if we want to simplify in our brain. And then my value for the pyrimidine here is the other equilibrium expression of 0.44 minus x. All right, so let's simplify to start solving for x. As I do that, we're going to go 1 times x squared is x squared, and then my value here is going to distribute into each part of that bracket. So the 1.7 E negative 9 times 0.44 is going to give me 7.48 E negative 10. All right, and then this value times x will be that value again. So minus 1.7 E negative 9x. So it's quadratic, and we need to set our quadratic up as a 0 equals. So what I'm going to do is move these items over to my positive x squared, which will simply switch the sign of them. So it's going to stay x squared, all right, and then it'll be plus 1.7 e negative 9x, and then minus 7.48 e negative 10. All right, and that's where we've got to use our solver and our calculator. So to watch this happen again, all right, we actually, I probably have an expression. Let me clear my calculator real quick. Dun, dun. Okay. So let's go ahead and go math, and then go down to solver. And then 0 equals, so let's go alpha x squared plus 1.7 e negative 9 x minus 7.48 e negative 10. We'll put in 2 as a hypothetical guess, and then alpha solve. And it gives me an answer. Now, it does try to give a negative number there. We will always take the absolute value because the number there is correct. So what I get here is that x equals 2.7 e negative 5 is what it said. And by the way, just in case you run into this problem, if I scroll over, I can get to that e negative 5. So be real careful in case it's hiding over there. So 2.7 e negative 5. All right. And keep in mind, this is the hydroxide concentration. The way I know it's the hydroxide concentration is the entire idea was solving for x. And x here does represent OH minus. So this makes sense. All right. Now, there's a couple things that it wants, though, going back to the question. All right, it's asking for an H plus concentration, and it's asking for the pH. All right, so this is just kind of, okay, well, I know this is what I ultimately want. So I've got my OH concentration here. So what I can do from here, and there's a couple different routes to go. One way is I could just take the negative log of this strong concentration. All right. And if you take the negative log of him, it's going to give you a look. It's from an OH, so it's going to give me a POH. All right. Which is neither of the things I'm looking for, but check it out. I can get my pH real easy now. All right, because I know that pH plus POH equals 14. All right. So I need the other value, which would be 9.43 would be pH. So there's one of my answers. All right, because those two numbers added together must equal 14. All right, but we also need a H plus concentration, which a couple different ways to figure that out. We could have used our OH minus initially and used KW, because remember the 1E negative 14 divided by that will give me the H plus. But since I went this route this time, I know that my other sneaky way is to go 10 to the negative 9.43 in this case. All right, oh, I meant to do it for you, I'm sorry. All right, so 10 to the negative 9.43 gives me an answer there. 3.7 e negative 10.